Hola, hi, this is Al, your statistics and probability instructor. Let's get to work. In this video, we will discuss how we can find the expected value of a function of a generic random variable y. Okay? Let me remind you that in another video we have already found the expected value of a transformation of a generic random variable y. The transformation that we talked about in that video was c times y, a constant times y. Okay, so another way of referring to that new variable, to that transformed new variable, would be w, right? And let me just say that, right? So in another video before, we talked about w equals c times y, where c is a constant. So another way of expressing w would be this: g of y equals c times y. Okay, so this is using a function notation to refer to w, to that transformation. Okay, so now what we want to do, right, is we would like to find the expected value of g of y, but for any function g of y. Okay, is that clear? So let me just say that now our goal, our objective, is finding the expected value of g of y for some function g of y. Not necessarily something like this, a constant times y, but a more general transformation. Make sense? Okay, so that's today's objective. Now that our objective is very clear, let's proceed. And as usual, our discussion will be based on an example. Okay? So what I want you to do is consider the following random variable y. I'm going to give you the probability distribution of y. Okay? Probability distribution of y. Again, let me remind you that when we use this term, probability distribution of a random variable, what we mean is a list of possible values with the corresponding probabilities. So we could provide that information either using a formula or a table. So in this case, I'm going to be giving you the probability distribution of y using a table. Okay, so those are the possible values for this random variable y, and then we have that the probability of minus 2 is going to be 1/5, Same goes for that possible value. -1 has the same probability of occurring. So anyway, all these possible values have the same probability of occurring. Okay, so these outcomes are equally likely. Okay, now we would like to do this. Find the expected value of y, and part B, we would like to find the expected value of w, where w now is a more complicated transformation, not like the one before where we just had y times a constant. Now we have a more complicated transformation. We are interested in finding the expected value of y square. Okay, so solution. The first one is going to be easy, right? We go, I just want the expected value of y, and I already have the probability distribution of that guy. Well, I'm going to be using the definition to find it. So by definition, the expected value of y equals, remember, possible value times its probability of occurring, right? Plus possible value times probability of occurring, and we do that for all possible values. So in this case, what we have is this: -2 times 1/5 plus -1 times 1/5 plus 0 times 1/5 plus 1 times 1/5, and finally 2 times 1/5. Now we note that in this case, since we have equally likely outcomes, we can factor out that 1/5. 1/5 is the same as well, this expression here is the same as 1/5 times -2. Let me write it down like this to stress that we have that negative sign there. Plus that -1 plus 0 plus 1 plus 2. You guys agree that this is equivalent to this? We are just factoring out that 1/5. But note that -2 and 2 will cancel out, -1 and 1 will cancel out, and we have a 0 here, so this is going to be 0 times 1/5. What we end up with is the expected value of y is 0. Okay? Now before we proceed, I want you to take a sec, and I would like you to guess what the expected value of this transformation is going to be. Okay? Think about what your intuition tells you the expected value of this transformation is going to be, and file it away. And then after we're done solving part B, then check whether or not your intuition matched with our result. Okay, so here we go. Let's try and solve part B, which is the ultimate goal. We are trying to use this example to see if there's a pattern that we can use to find the expected value of more general transformation of a random variable. Okay. So if you remember what we did in another video where we discussed this transformation, C times Y, remember when we talked about the profit, right? Okay, so anyway, what we did back then when we talked about the profit in two different locations where cell phones were sold, right? What we did is, hey, we want to find the expected value, right? And at this point, what we have been using to find expected values is the definition. And to use the definition, what we need is the probability distribution of the random variable in question, right? Okay, so that again will be our first step. Let's find the probability distribution of W. So probability distribution of W. Let me use lowercase w to refer to the possible values of the random variable W. We use uppercase to refer to the random variable, and lowercase to refer to possible values. Okay, and then the corresponding probability. So remember that W equals random variable Y square. Okay, so possible values of Y, -2. If you square it, then you end up with a 4, right? Let me write it down here. Note that if you square +2, you also end up with a 4. So, okay. -1 square. -1 square equals 1. Note that 1 square also equals 1. So another possible value will be 1. And the other one, the remaining possible value for the random variable Y, the original random variable, is 0. And if you square it, well, you end up with a 0 again. Okay? Okay. Now, we need, again, remember probability distribution is just give me the list of possible values with the corresponding probabilities. So probability of observing W equals 0. That is the same as the probability of Y being 0. If Y equals 0, then Y squared is going to be 0, and that happens with probability 1 over 5, right? So we have 1 over 5 here. Okay. Next, probability that W equals 1. Well, that happens if Y happens to be -1, or if Y equals 1, right? Because if Y equals -1, when you square it, you end up with a 1. W equals 1. And also, if Y happens to be 1, when you square it, you end up with a 1, and then W is equal to 1. So we have the probability of a union of mutually exclusive events. So the probability is going to be, the probability of that union is going to be the sum of these two probabilities. So it's going to be 1 over 5 plus 1 over 5. So 2 over 5. Okay, making progress. Can you see that we have a similar situation for that value, for W being equal to 4? W will be 4 if Y is -2 or if Y is +2. And that happens with the same probability as this. Now, my suggestion is that if you can, when you're dealing with a transformation and you're finding the probability distribution of that transformation, check that the probability distribution of that transformation satisfies the properties of a legit probability distribution. So in this case, these three numbers are numbers between 0 and 1. Check. Okay, that's a property of a legit probability distribution, and when you add them all up, you end up with 5 divided by 5, which is 1, and that's the other feature, the other characteristic, the other property that legit probability distribution must satisfy. Okay, so it seems that we're doing well, we're on the right track. This is a legit probability distribution, and going back to the original problem, let's find the expected value of W. Now that we have the probability distribution, we will just use the definition to find it. Okay, so by definition, the expected value of W will be just 0 times probability of 0 plus 1 times probability of observing a 1, 4 times probability of seeing a 4. The first one is going to be a 0, then we have 2 over 5, and then we have 8 over 5. That happens to be 10 divided by 5, which is the same as 2. So expected value of W equals 2. Okay? Easy, right? Okay. Now, let's try and explore a different route. Instead of finding the probability distribution of W and then applying the definition of expected value, we would like to use the probability distribution of the original variable Y to find the expected value of W. Okay? Makes sense? So what we're trying to do in this alternative route is there a way of skipping this? Is there a way of skipping this step in the process? Because we had to find the probability distribution of W before we could find the expected value of W. So the next the next thing that we're going to be doing is seeing if there's a way of just using the probability distribution of y, and directly from using the probability distribution of y, finding the expected value for w, for that transformed random variable. Make sense? Okay. So let's just say that we're trying another route. Another way. Okay. So, to do that, we are going to observe a few things here, right? So, by definition, the expected value of w happens to be 0 times probability that w equals 0. You guys agree? We have the same for the other possible value, 1 times probability that w equals 1 plus 4 times the probability that w equals 4. Okay, that's just using our definition. Now, if you take a closer look at our table, that guy there, the probability of w being equal to 0 is the same as this, right? Probability that y equals 0, right? Probability that w equals 1, well, in that case, and remember that we mentioned this, the probability that w equals 1 is the probability that y equals -1 plus the probability that y equals +1. And then we have something similar for 4, right? So it's going to be 4 times probability that y equals -2 plus probability that y equals +2. You guys agree? Now let's expand this. So, first one, no problem. That's the same thing. That's going to be just this guy. Let me copy and paste. We have this one here. Next one is going to be 1 times this. Okay. And then we have 1 times this. 1 times the probability that y equals 1. So let me write it down here. Okay. Again, 1 times probability that y equals -1. This guy. 1 times probability that y equals 1. Okay. And then we do the same thing with this guy here. Let me copy and paste these guys, and I'm going to modify those accordingly. So we have 4, and then we have a -2, we have 4 and +2. That would be doing this. 4 times probability that y equals -2 plus 4 times probability that y equals +2. Okay. But now we are going to make another comment, another observation. Interesting. We're going to rewrite that expression. 0 is the same as 0 squared. 1, well, 1 happens to be the same as -1 square. This one is the same as 1 square. 4, you see where I'm going, right? Is the same as -2 square. And 4 is the same as 2 square. Right? You guys agree? So, if we were to use symbols, right, to summarize what we have found, note that 0, -1, 1, -2, and 2 are the possible values for the random variable y, right? So let me use that fancy sigma notation like this. That's the same as lowercase y because it's a possible value, right? For y square times the probability that the random variable uppercase y assumes that particular value. Make sense? And remember, lower cases represent possible outcomes. So lowercase y stands for either 0 or -1 or 1 or -2 or 2. And we're doing this for all y's. Okay? All y's. Okay? But now, using more notation, what we said is w, right, is a function of y. So, well, let me say this, right? So what we have found is, hey, the expected value of w, and w represents y square, happens to be the same as the sum for all y's of y square times probability of y equals y, right? So we have something like this. Let me write it down like that. Expected value of y square equals this. Well, another way of writing this would be expected value of a function of y equals g of y times the probability distribution of the original random variable y. Can you see? In our particular case, in our example, g of y equals y square, right? But in general, it turns out that if you're looking for the expected value of g of y, where g of y is a function of your original random variable, what this is telling you is, don't worry, you don't need that intermediate step. You don't need to find the probability distribution of your transformation and then find the expected value. If you want, you can use the probability distribution of the original random variable y and then just multiply each of those values by the transformation and then add them all up for all possible values of y. Makes sense? So that is the take-home message. Okay? Now, let me show you the statement of the theorem. That's Theorem 3.2 from our textbook, right? And that's basically what we have done here. We showed a particular case of this theorem where g of y was y square. Okay? Makes sense? And again, remember, the advantage of this theorem is that you don't need to find as an intermediate step the probability distribution of your transformation of what we called W. You can find the expected value of W directly using the probability distribution of the original random variable y. Okay? Now, if you have time, there's a proof there in our lecture notes, so take a look at it. Please read it. That would be kind of a homework problem. Let's say that. Reading proof of theorem 3.2 homework. Okay, well, that's it for now. Please take care and keep working hard. See you next time. Bye.